You climb a narrow stone staircase in the dark. The steps are worn smooth by years of feet, spiraling upward through the interior of an old building in Padua. Your hand trails along the cold wall for balance. The air grows cooler with each step. Above you, a wooden trapdoor is open, and through it you can see a rectangle of night sky, deep black, scattered with stars so bright they seem close enough to touch. You are climbing toward the Rooftop Observatory of Galileo Galilei. It is January 7th, 1610. Tonight, without knowing it yet, this man will change the way humanity understands the universe. You reach the top step and emerge into the open air. The rooftop is flat and wide, paved with terracotta tiles that are cold beneath your feet. A low stone wall runs along the edges, waist high, offering a view of Padua spreading in every direction. The city is dark and quiet, its terracotta rooftops a patchwork of shadow under the starlight. A few windows glow with candlelight. The towers of the university and the basilica rise as dark shapes against the sky. The air is sharp and cold, the kind of cold that clears your mind and makes every sensation vivid. Your breath comes out as small white clouds that hang for a moment and vanish. Winter in northern Italy. The sky is extraordinary. Galileo is here. He stands near the center of the rooftop, bent over a wooden tripod, making fine adjustments to the instrument mounted on it. He's 45 years old, stocky, with a reddish beard going grey at the edges and sharp, restless eyes. He wears a heavy wool cloak over his university robes and a knitted cap pulled low against the cold. His fingers are red with cold, but they move with precision, turning a small brass screw on the side of the telescope. He does not look up at your arrival. He is entirely absorbed. This is a man who, once focused, forgets that anything else exists. The telescope stands on its tripod, like a long brass finger pointing at the sky. It is not impressive to look at. It is a tube, perhaps a meter long, made of leather-covered cardboard with brass fittings at each end. The lenses are small, no larger than coins. The tripod is rough wood, sturdy but inelegant. This is not the gleaming instrument of a wealthy patron. This is a tool built by a man who ground his own lenses, who taught himself optics by trial and error, who spent months perfecting the curvature of each piece of glass. It looks ordinary. It is about to become the most important scientific instrument in history. The sky above Padua is remarkable tonight. There is no moon yet, and the air is unusually clear, free of the haze and cloud that often blankets the Po Valley in winter. The stars are vivid and sharp, thousands of them, scattered across the darkness in patterns that humans have named and storied for millennia. Orion stands in the south, his belt 3 bright points in a perfect line. The Pleiades cluster glows in the west, a small, tight knot of blue-white light. The Milky Way stretches overhead like a river of luminous fog, its structure hidden from the naked eye, appearing as nothing more than a pale, continuous band. Galileo looks up from his telescope and studies the sky with his naked eyes first. He always begins this way. A small table stands beside the telescope, covered with papers, a brass inkwell, and several quill pens. A candle burns in a glass lantern, its flame protected from the wind by the glass walls. The lantern casts a small circle of warm light on the table and the papers, creating a tiny island of gold in the blue darkness of the rooftop. Galileo's observation journal is open to a fresh page. The date is already written at the top in his careful angular hand. Below it, nothing. The page is blank, waiting for whatever the night will reveal. Beside the journal, a star chart, hand-drawn, showing the positions of the major constellations. It is about to become obsolete. The cold is steady and penetrating. It comes from everywhere at once, from the stone beneath your feet, from the open sky above, from the winter air that moves gently across the rooftop. Your fingers grow stiff, your nose runs, your cheeks burn. Galileo seems not to notice. He's been out here for hours already, waiting for the sky to darken fully, waiting for the stars to sharpen, waiting for the conditions to be perfect. Astronomers learn patience before they learn anything else. The sky will not hurry for anyone. You pull your cloak tighter and breathe into your hands. The cold is the price of admission to the show that is about to begin. Padua sleeps below you. The city is one of the oldest in Italy, home to a university that has been teaching since 1222. Galileo has been a professor here for 18 years, teaching mathematics, geometry, and mechanics. He is respected, but not famous. He earns a modest salary and supplements it by selling compasses and giving private lessons. He has 3 children. He argues with colleagues. He worries about money. He is, in almost every way, an ordinary man. But he has one quality that separates him from everyone else alive. He looks at things. He looks at things that everyone else has seen, and he sees what they have missed. Tonight, he will look at Jupiter and see something no one has ever seen. A cat has followed you up the stairs and now sits on the stone wall, its eyes reflecting the starlight in 2 small green points. It watches Galileo with the patient curiosity of an animal that has seen this routine many times. The man goes up to the roof. The man looks through the tube. The man writes things down. The cat does not understand the significance. It does not need to. It is content to sit in the cold and watch, the way it watches birds and mice and the movement of shadows. You sit on the wall beside the cat and wait. The cat approves of your stillness. It leans slightly against your arm. Galileo straightens up from the telescope and stretches his back. He looks at you, as if noticing you for the first time, and nods. His expression is focused, expectant, the face of a man about to open a door and not knowing what is on the other side. He gestures toward the telescope. He wants you to look first. He wants to share what he has found. This generosity is essential to who Galileo is. He does not hoard knowledge. He publishes it, argues for it, fights for it. He believes that truth, once discovered, belongs to everyone. He steps aside, and you approach the telescope. The brass eyepiece is cold against your eye. You close one eye and press the other against the small lens at the end of the tube. At first, you see nothing. Darkness. Then your eye adjusts, and the field of view comes alive. A circle of sky, sharply magnified, fills your vision. The stars within that circle are brighter, clearer, more numerous than anything you have seen with your naked eyes. Each one is a point of white fire, steady and sharp, pinned to the black velvet of space. The telescope does not just magnify, it reveals. It shows you things that have always been there, but that your eyes alone could never detect. You are looking at the sky the way Galileo looks at it, and the sky has suddenly become a different place. You pull back from the eyepiece and blink. The rooftop seems darker after the bright field of the telescope. Your own vision feels suddenly inadequate, blunt, limited. You look up at the sky with your naked eyes and see the same stars you have always seen, the same patterns, the same pale band of the Milky Way. But now you know there is more. Behind every visible star, 100 invisible ones. Behind every patch of darkness, light that only the telescope can find. The universe has expanded in the time it took to press your eye against a piece of curved glass. Galileo watches your face and smiles. He knows the feeling. He felt it too. The first time, Galileo takes the telescope and tilts it downward toward the horizon, where the moon has just begun to rise. It is a waning crescent tonight, a thin sliver of light climbing above the eastern rooftops. Through the naked eye, it looks as it has always looked, a smooth, luminous curve, the perfect celestial body that Aristotle described 2,000 years ago. Aristotle said the heavens were made of a perfect, incorruptible substance. The moon was a flawless sphere. This had been accepted wisdom for 20 centuries. Galileo adjusts the focus with a small turn of the brass tube and steps back. He gestures for you to look. You press your eye to the lens, and the moon fills your vision. The shock is physical. The surface is not smooth. It is rough, pitted, scarred, mountainous. Craters of every size cover the illuminated portion, their rims casting long shadows in the low-angled sunlight. Mountain ranges rise along the terminator, the line between light and dark, their peaks catching the sun while their valleys remain in shadow. The moon is not a perfect sphere. It is a world, a landscape, a place with geography as complex as the Earth's. Aristotle was wrong. 2,000 years of certainty, overturned in a single look through a brass tube. You stare. You cannot stop staring. Galileo speaks quietly beside you, pointing out features. The dark, flat areas that he calls Maria sees, though he suspects they are not water. The bright highlands, rough and cratered, older than the plains. The long shadows cast by crater walls, which he has used to calculate the height of lunar mountains. Some are taller than the Alps, he says. His voice carries the controlled excitement of a man who has been living with this knowledge for weeks and still cannot quite believe it. He has drawn the moon. His sketches are on the table, wash drawings in brown ink, showing the craters and mountains with an artist's eye and a scientist's precision. The moon that humanity has worshipped and poeticized for 10,000 years is a ball of rock. And it is beautiful. Galileo takes the telescope from the tripod and holds it in his hands, showing you the construction. 2 lenses, he explains. The objective lens at the front is convex, bulging outward, designed to gather light and bend it inward. The eyepiece at the back is concave, curving inward, designed to spread the focused light into an image that your eye can interpret. The distance between the 2 lenses determines the magnification. Galileo has achieved 20 times magnification with this instrument, far beyond the 3 or 4 times that the Dutch spectacle makers who invented the telescope could manage. The secret is in the grinding. Each lens must be shaped to a precise curvature, polished until its surface is perfectly smooth. Galileo did this himself, hour after hour, day after day. He lets you hold one of the spare lenses. It is small, no wider than a large coin, and surprisingly heavy for its size. The glass is pale green, the color of Venetian glass, with a slight imperfection near one edge where an air bubble was trapped during cooling. You hold it up to the candlelight, and the world warps and bends through its curved surface. The candle flame becomes a streak of golden light. The stars behind it blur and swim. This small piece of glass, imperfect and handmade, is enough to rewrite the map of the universe. The power is not in the glass. It is in the mind that knew what to do with it. Galileo remounts the telescope and points it at the moon again. He wants you to see the terminator, the shadow line that divides the illuminated half from the dark half. Along this line, the sun's light arrives at a low angle, casting long shadows that reveal the topography with extraordinary clarity. You see a mountain peak catching the sunlight, while the land around it is still in darkness. A bright point floating in the shadow, like a star that has fallen onto the moon's surface. Galileo explains that this is how he measures the mountains. He calculates the distance from the bright peak to the terminator, uses geometry, and derives the height. Mathematics, he says. Mathematics reveals what the eye alone cannot. You step back from the telescope and look at the moon with your naked eyes again. The thin crescent hangs above the rooftops, the same crescent that lovers and poets and farmers and sailors have looked at for millennia. But you cannot see it the same way anymore. You know what is there now. Behind that smooth, luminous surface, mountains and craters and vast, flat plains. The moon has become a place, not a light, not a symbol, not a god. A place, somewhere you could stand, if you could get there. Somewhere with its own horizons and shadows and geography. Galileo has not just changed what you see. He has changed what seeing means. The cold has intensified while you were looking at the moon. Your fingers are numb. Your ears sting. Galileo produces a flask from inside his cloak and offers it to you. It is wine, red and rough, warmed slightly by the heat of his body. You drink. The wine is not good, but it is warm, and the warmth spreads through your chest like a small fire lighting in a cold room. Galileo drinks too. A long pull, then wipes his beard with the back of his hand. He screws the cap back on and tucks the flask away. The observatory is not a comfortable place. It is a workplace. The wine is not for pleasure. It is fuel. There is more to see tonight. Galileo explains how he came to build the telescope. He heard rumors from Holland, he says, of a device made by a spectacle maker that could make distant objects appear close. He had never seen one. He simply worked out the principles from a description and built his own, better than the original, in a single night. This is how Galileo's mind works. Give him a problem, and he cannot rest until he has solved it. Give him a tool, and he will improve it. Give him a mystery, and he will not sleep until he has taken it apart and understood every piece. The telescope in your hands is the product of that restlessness, that inability to leave anything unknown. You look at the moon one more time through the telescope. This time, you notice the earth shine, the faint illumination of the moon's dark side by light reflected from the earth. The dark portion of the crescent is not completely dark. It glows with a dim, ghostly light, just bright enough to reveal the outlines of craters and Maria. Galileo points at it and explains. The earth shines, he says. We reflect the sun's light just as the moon does. To someone standing on the moon, the earth would be a bright disk in the sky, and it would illuminate the lunar night. The earth is a lamp. We just never see our own light, because we are standing on it. Galileo swings the telescope toward the west, where the Milky Way stretches across the sky in a broad, luminous band. To your naked eyes, it looks like a pale cloud, a smear of light with no discernible structure. It has been there every clear night of your life, and you have never thought much about it. The Greeks believed it was milk spilled from the breast of Hera. The Romans called it Via Lactea, the Milky Road. Everyone has a story for it. No one has looked at it closely. No one has had the means. Galileo has the means. He steadies the telescope, adjusts the focus, and beckons you forward. You look through the eyepiece, and the Milky Way explodes. The pale cloud dissolves into thousands, tens of thousands of individual stars. Each one is tiny but distinct, a pinpoint of white light, and together they are packed so densely that they merge into a continuous glow when seen without magnification. It is like looking at a beach from a distance and seeing only sand, then kneeling down and seeing that the sand is made of individual grains, each one different, each one its own small world. The Milky Way is not a cloud. It is a crowd, an uncountable gathering of suns, each one perhaps as large as your own sun, each one shining its light across unimaginable distances. Your mind struggles to hold the scale of what you are seeing. Galileo is writing. His quill scratches rapidly across the page, recording what you are both seeing. He draws a small circle to represent the telescope's field of view, then fills it with dots, each dot a star, placing them as accurately as he can from memory, and quick glances back through the eyepiece. The page fills quickly. There are more stars than he can draw. He writes a note beside the sketch. Innumerable stars. 2 words that overturn centuries of cosmology. If the Milky Way is made of stars, the universe is enormously larger than anyone has imagined. The stars are not a fixed sphere surrounding the Earth. They extend in every direction, to depths that no telescope can fully reveal. You move the telescope slightly, scanning along the length of the Milky Way, and the stars continue to multiply. Every patch of sky that looked empty to your naked eyes is full. The darkness between the bright stars is not empty. It is filled with fainter stars, and behind those, fainter ones still. It is stars all the way down, an infinite regression of light. The universe is not a small, neat room with the Earth at its center. It is an abyss, vast and deep, populated by more suns than any human can count. You feel a moment of vertigo, as if the rooftop has tilted beneath you, and you are falling upward into the sky. Then the vertigo passes, and what replaces it is wonder. Pure, uncomplicated wonder. Galileo points the telescope at the Pleiades, the small cluster of stars visible to the naked eye as a tight group of 6 or 7 blue-white points. Through the telescope, the cluster blossoms. The 6 become 30, 40, more. Stars hidden within the cluster, too faint for the naked eye, appear everywhere, filling the spaces between the bright ones. The Pleiades are not 6 stars. They are a family of dozens, perhaps hundreds, all bound together by gravity in a volume of space that looks tiny but spans light years. Galileo counts as many as he can and sketches their positions. Every time he thinks he has found them all, another one appears at the edge of vision, faint but real. He turns the telescope to Orion's belt and the region around it. The 3 bright stars of the belt are unchanged by magnification. They are too bright and too close to benefit from the telescope's power. But around them, in the sword of Orion and the surrounding area, new stars appear by the dozens. A faint, luminous patch that the naked eye can barely detect resolves into a dense cluster of stars embedded in a glowing cloud. This is the Orion Nebula, though Galileo does not use that word. He simply records what he sees. A foggy region that resolves into stars. He does not know what the fog is. That mystery will wait for later centuries. For now, the stars are enough. The quill continues to scratch. The candle in the lantern has burned lower, and Galileo pauses to trim the wick with a small knife, restoring the flame to its full brightness. The trimmed wick produces a cleaner light, and the small circle of gold around the table seems to intensify. In that circle of light, on a cold rooftop in Padua, a man is writing the first accurate account of what the sky actually contains. Not mythology, not philosophy, observation, measurement, record. This is the birth of modern astronomy, happening in real time, one quill stroke at a time. The ink glistens wet on the page for a moment, then dries in the cold air, becoming permanent. You sit on the stone wall and look up at the sky without the telescope. It looks different now. Every point of light carries a new weight, a new implication. Each visible star is one among millions. The darkness between them is not empty, but full. The pale band of the Milky Way is not a cloud, but a galaxy, though that word will not be used for centuries yet. You are looking at the universe the way people will look at it for the rest of time, knowing that it is larger, deeper, and more populated than any single human mind can comprehend. Galileo has not just shown you the sky. He has shown you the limits of your own perception and the power of a tool to extend it. Galileo moves the telescope to a dark patch of sky, a region where the naked eye sees nothing at all. He asks you to look. You do. And there, in what appeared to be empty blackness, stars appear. Dozens of them. Faint, tiny, but unmistakably real. The sky has no empty spaces. Everywhere you look, at every magnification, there are more stars. The universe is not a backdrop. It is not a painted ceiling. It is a depth, an abyss of light, extending in every direction, further than any instrument can reach. This single observation, stars where there appeared to be nothing, is perhaps the most unsettling discovery of the night. Absence is an illusion. The universe is full. The cold makes the air exceptionally still tonight, which is why the seeing is so good. Turbulence in the atmosphere blurs telescope images, making stars dance and shimmer. But when the air is cold and still, the light travels straight and the images are sharp. Galileo calls these good nights, and he has learned to predict them. Cold, clear, no wind, no cloud, no moon to wash out the fainter stars. These are the conditions he waits for, sometimes for weeks. When they arrive, he stays on the rooftop until dawn, extracting every minute of clarity from the patient sky. Tonight is one of the best nights he has ever had. The universe is cooperating. Galileo adjusts the telescope again. This time, he aims it at a bright point of light in the east, above the horizon, steady and unwavering. It is Jupiter, the largest planet in the solar system, named for the king of the Roman gods. To the naked eye, Jupiter is simply a bright star, one of the wandering stars, the planets, that move slowly against the fixed background of the constellations. Tonight, Galileo has a particular reason for looking at Jupiter. He has been observing it for several nights and has noticed something strange. 3 tiny points of light that seem to follow the planet, changing their positions from night to night. You look through the eyepiece. Jupiter appears as a small, bright disk, not a point like the stars, but a visible circle, creamy white, with a hint of banding across its surface. And there, arranged in a line beside it, 3 tiny dots of light. They are faint but unmistakable, aligned with the planet's equator, 2 on one side and 1 on the other. They look like very faint stars that happen to be near Jupiter. But they are not stars. Galileo has been tracking them for 4 nights now. They move. Each night, they shift their positions relative to the planet, sometimes closer, sometimes farther, sometimes changing sides. They are not background stars. They are orbiting Jupiter. The implications are enormous, and Galileo knows it. If Jupiter has moons, then not everything in the sky orbits the Earth. There is another center, another hub, another world with its own satellites. The Aristotelian model, which places Earth at the center of all motion, cannot explain this. Copernicus was right. The Earth is not the center. It is one of several planets orbiting the Sun, and other planets have their own moons, just as Earth does. Galileo does not say any of this out loud. He simply records what he sees. 3 small points of light beside a bright disk. The data speaks for itself. The revolution is in the dots. He draws the positions carefully. A circle for Jupiter. 3 small dots, each one placed with reference to the planet's edge. He notes the date and time. He notes the seeing conditions, the clarity of the air, the altitude of the planet above the horizon. He is building a case, observation by observation, night by night. In a few weeks, he will observe a 4th moon. He will publish his findings in a small book called Sidereus Nuncius, the Starry Messenger. It will make him the most famous scientist in Europe. It will also bring him to the attention of the Inquisition. But that is years away. Tonight, there is only the telescope, the planet, and 3 impossibly small lights. You look at Jupiter again. The 3 dots are motionless in the eyepiece, as if fixed in place. But they are moving. Everything in the sky is moving. Jupiter is moving around the Sun. The moons are moving around Jupiter. The Earth beneath your feet is moving around the Sun. The Sun itself is moving through the galaxy. Nothing is still. The entire universe is in motion. A vast, silent dance of gravity and light, too slow for human eyes to perceive in a single night, but inexorable, continuous, eternal. You are standing on a moving platform, looking through a brass tube at another moving platform, watching smaller platforms move around it. And all of this is silent. The biggest movements in the universe make no sound at all. Galileo speaks softly. He tells you that he has named the moons the Medicean stars in honor of the Medici family, whose patronage he hopes to secure. It is a practical decision. Science requires funding, and funding requires powerful friends. The moons will later be renamed Io, Europa, Ganymede, and Callisto, the lovers and companions of Jupiter in myth. But tonight they have no names. They are simply lights, new lights in a sky that humanity thought it knew completely. Galileo's voice is calm as he explains this, but his eyes are not calm. His eyes are the eyes of a man standing at the edge of an ocean he has never seen before. The cold deepens. Your breath comes in longer plumes now, lingering in the still air before dissolving. Galileo wraps his cloak tighter and blows on his fingers before picking up the quill again. Astronomy in 1610 is a physical ordeal. There are no heated observatories, no computer-controlled telescopes, no digital cameras. There is only a man on a roof in the cold, looking through a tube, writing with numb fingers by the light of a single candle. Every observation is won by endurance. Every sketch is made with hands that can barely feel the pen. The data that will change the world is being collected, one frozen minute at a time. You look at Jupiter one more time. The 3 dots are still there, steady and patient, orbiting a world that is 500 million miles away. The light that enters the telescope left Jupiter 40 minutes ago, traveling at the speed of light across the empty space between the 2 planets. You are seeing Jupiter not as it is, but as it was, 40 minutes in the past. The moons you are looking at have already moved since the light that shows them departed. Astronomy is always an exercise in looking backward, seeing the past painted on the present sky. The deeper you look, the further back in time you see. The stars are the memory of the universe, written in light. You try to imagine what the moons of Jupiter look like up close. Each one is a world. Io, though you do not know its name yet, is a hellscape of volcanoes and sulfur. Europa is an ice world with an ocean hidden beneath its frozen surface. Ganymede is larger than the planet Mercury. Callisto is ancient and cratered, its surface unchanged for billions of years. None of this is known in 1610. To Galileo, they are simply lights, 3 tiny dots that move. But you know what they will become. Worlds explored by spacecraft, photographed in detail, mapped and studied. The dots you see tonight are the seeds of missions that will not fly for 400 years. Galileo asks you what you see. His tone is careful, almost clinical. He wants independent confirmation. He wants to know that the dots are not a defect in the lens, not an artifact of his tired eyes, not a trick of the cold air. This is the scientific method before anyone has named it. Observe, record, seek confirmation. Question your own perception. Trust the data over the theory. Galileo does not yet know that he is inventing a new way of understanding the world. He is simply being thorough. He is simply being honest. The dots are there. You see them too. 2 observers, 2 sets of eyes, the same 3 points of light. The evidence holds. Galileo sets the telescope down and moves to the table. The observations are complete for tonight. Now comes the other half of the work, the recording, the thinking, the writing. He sits on a wooden stool, pulls the candle lantern closer, and opens his journal to the page he began earlier. His hand is steadier now. The excitement of the observation has settled into the quieter excitement of understanding. He dips his quill in the inkwell and begins to write, the iron nib scratching softly against the paper. The sound is small and rhythmic, like a mouse running across a wooden floor. In the silence of the rooftop, it is the loudest sound there is. He draws Jupiter first, a careful circle, larger than the ones representing the moons, with subtle shading to suggest its disc-like appearance through the telescope. Then the 3 dots, placed precisely, each one at the correct distance and angle from the planet's edge. He uses a ruler to draw the line of the ecliptic, the plane in which the moons appear to orbit. The drawing is scientific, not artistic, but it has a beauty that comes from precision. The beauty of something done exactly right. Each dot is a world. Each line is a measurement. The page is becoming a map of a place that no one has mapped before. His hand shakes. You notice it as he writes the annotation beside the drawing. The letters are slightly uneven, the lines of text not quite straight. It could be the cold. His fingers have been exposed to the winter air for hours, but watching his face, you think it might be something else. This man knows what he has found. He knows that these 3 small dots beside a bright planet are evidence that the Earth is not the center of the universe. He knows that this discovery will challenge the church, the universities, the entire intellectual framework of his world. The pen shakes because the hand that holds it is holding a truth too large for one person to carry alone. The candle flame flickers as a breath of wind crosses the rooftop. The shadows jump and settle. Galileo pauses, waits for the flame to steady, and then continues. He writes in Italian, not Latin. This is a deliberate choice. Latin is the language of scholars, of the church, of the educated elite. Italian is the language of everyone. Galileo wants everyone to understand what he has found. He believes that the universe belongs to all people, not just to those who can read ancient languages. This small act of writing in the vernacular is as revolutionary as the observations themselves. He is democratizing the sky. You sit beside him and watch the words appear. The ink is iron gall, the standard writing ink of the period, made from oak galls, iron sulfate, and gum arabic. When first applied, it is pale, almost invisible. But as it dries and reacts with the air, it darkens to a rich, warm brown that will remain legible for centuries. The words Galileo writes tonight will be read by Isaac Newton, by Albert Einstein, by every astronomer who follows. The ink is drying on the page right now, turning from nothing to something, from invisible to permanent, in the same way that his observations are turning from private experience to public knowledge. He finishes the entry and sets the quill down. He leans back on the stool and stretches, his joints cracking in the cold. He looks at what he has written, reads it once, nods slightly, and closes the journal. The leather cover falls shut with a soft sound. The observations of January 7th, 1610, are now part of the permanent record. Galileo will return tomorrow night, and the night after, and for many nights to come. He will watch the moons change position. He will discover a fourth moon. He will calculate their orbital periods. Each night's observations will build on the last, brick by brick, until the evidence is overwhelming. But this night, this first complete record, this is the foundation. Everything else will rest on this. The flask of wine appears again. Galileo drinks, then offers it to you. The wine has cooled further, but it still carries a warmth that the night air cannot provide. You drink and feel it settle in your stomach, a small pool of heat. Galileo looks up at the sky. not through the telescope, but with his naked eyes. His face is tilted upward, his expression open, almost childlike. After all the measuring and recording and calculating, after all the science, there is still this: a man looking up at the stars and feeling awe. The awe does not diminish with understanding. It deepens. The more you know about the sky, the more remarkable it becomes. He speaks quietly, almost to himself. He talks about what comes next. He will write a book. He will call it Sidereus Nuntius, the Starry Messenger. He will publish it in Venice, where the printing presses are fast and the censors are lenient. He will send copies to every astronomer in Europe, to every court, to the Pope himself. He wants the world to see what he has seen. He wants everyone to look up and know the truth. His voice is calm, but there is an urgency beneath it. The urgency of a man who has been given a gift so enormous that keeping it to himself would be a kind of theft. While Galileo writes, you pick up one of the star charts on the table. It shows the sky as the ancients understood it, the constellations drawn as mythological figures, the stars as fixed points on a crystalline sphere. The chart is beautiful but wrong. The sphere does not exist. The stars are not fixed. They are scattered through space at different distances, some close, some unimaginably far. The chart in your hands is a portrait of human ignorance, lovingly rendered in ink and gold. After tonight, it belongs to the past. New charts will be drawn, new maps made, new atlases compiled. Each one will be closer to the truth and further from the myths. Progress is beautiful. But something is also lost. The journal is full of numbers. Galileo records everything in numbers because numbers do not lie. The angle of the telescope, the time of each observation, the distance between Jupiter and each moon, measured in Jupiter diameters, the altitude of each object above the horizon. Numbers are the language of nature, he believes. They are the grammar of the universe. Every beautiful thing can be measured, and measuring it does not make it less beautiful. It makes it more knowable, more shareable, more permanent. A poem about the moon is beautiful. A measurement of the moon's mountains is also beautiful. They are different languages describing the same wonder. The eastern sky has changed. The deep black has given way to something less absolute, a darkness that is no longer quite dark, tinged with the faintest suggestion of blue. Dawn is still an hour away, but its approach is already changing the quality of the night. The stars near the eastern horizon have begun to fade, their light overwhelmed by the first photons of the approaching sun. The brighter stars remain, but they seem diminished, as if they know their time is ending. Galileo notices the change and begins to pack away his instruments. The night's work is done. The sky is closing its book until tomorrow. He collapses the telescope carefully, sliding the tubes together, and wraps it in a cloth. The lenses are precious, irreplaceable, each one the product of days of grinding. He handles the instrument with the tenderness of a parent holding a child. The The telescope is placed in a wooden box lined with felt, and the box is closed and latched. The tripod is folded and leaned against the wall. The observation table is tidied, the inkwell capped, the quills placed in their holder. The journal goes inside Galileo's cloak, close to his body, where it will stay warm and dry. These rituals of closing are as practiced as the rituals of opening. Every night ends the same way. The candle in the lantern has burned down to a stub, its flame barely an inch above the melted wax. Galileo does not extinguish it. He lets it burn to its end, a small courtesy to the fire that has kept his pages visible through the long, cold hours. You watch the flame together. It flickers, steadies, flickers again, and then gently goes out, sending a thin line of smoke straight up into the still air. The rooftop darkens. The only light now comes from the stars above and the faint pre-dawn glow in the east. Your eyes adjust slowly, and the world resolves into shades of blue and grey. Galileo looks up at the sky one final time. Jupiter is still visible in the east, bright and steady, its secret moons invisible to the naked eye, but present, orbiting, patient. The Milky Way has faded as the sky has lightened, but it is still there, a pale suggestion of the river of stars that the telescope revealed. The moon has risen higher, its crescent brighter now against the paling sky. Everything Galileo discovered tonight is still up there, unchanged, waiting for the next night, the next look, the next page in the journal. The sky does not care about human schedules. It simply continues. Observation or no observation. Discovery or no discovery. Turning its ancient wheel. The city of Padua is beginning to stir. A church bell rings in the distance, a single low tone that carries across the rooftops and fades into the last of the night. A rooster crows somewhere below. A shutter opens. The sounds of a city waking are the same in 1610 as they will be in any century. The slow, reluctant transition from sleep to wakefulness, from stillness to motion. Galileo listens for a moment, then gathers his cloak around him. He looks tired. His face is lined with cold and concentration. But his eyes are still bright, still restless, still looking for the next question. A man like Galileo never runs out of questions. He only runs out of nights. He turns to you and nods, a small gesture of farewell, or perhaps of thanks for your company through the long, cold hours. Then he descends through the trapdoor, his heavy cloak disappearing into the darkness of the stairwell, his footsteps fading on the stone steps. You are alone on the rooftop. The stars are nearly gone. Venus burns bright in the east, the morning star, the last to surrender to the dawn. You sit on the stone wall and feel the cold beneath you and the fading night above you. The universe is larger tonight than it was yesterday. Jupiter has moons. The Milky Way is made of stars. The moon has mountains. And a man on a rooftop in Padua has just told the world. You stay a moment longer. The cat is still here, curled against the stone wall, asleep despite the cold, its body a small, warm circle of fur. You rest your hand on its back and feel the vibration of its purr, steady and unconcerned with the revolution that has taken place above its head. The sky brightens by degrees. The blue deepens. The first true light of dawn appears as a golden line at the eastern horizon, thin and sharp, like a crack in the wall of night. Through that crack, the light of a new day pours in. It is the same sun that Copernicus placed at the center. The same sun that Galileo has now proven is the center. It rises as it always rises, indifferent to the small creatures on the small planet that circles it. The stars are gone. The sky is blue. The rooftops of Padua are catching the first warm light of morning, their terracotta tiles turning from grey to orange as the sun climbs. The bell tower of the university is lit from the east, its stone face glowing. Below, the streets are filling with the sounds of the day, carts and voices, and the opening of doors. The night is over. But what happened during the night will never be over. It will ripple outward through centuries, through Newton and Einstein and Hubble, and every astronomer who ever pointed a lens at the sky. It started here, on this rooftop, with a brass tube and a pair of curious eyes. Close your eyes now. Rest. The universe will keep turning. It has nowhere else to be. You think about what Galileo does not know. He does not know about galaxies, about light years, about the expansion of the universe. He does not know that there are 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. He does not know about black holes, about neutron stars, about the cosmic microwave background radiation left over from the Big Bang. He does not know that the universe is 13.8 billion years old. He is standing at the very beginning of a journey that will take humanity centuries to travel. He has taken the first step. He has opened the door. Everything that follows, every telescope, every spacecraft, every equation, begins here. The rooftop is quiet now. The telescope is packed. The journal is inside Galileo's cloak. The table is bare, except for the extinguished lantern and a few drops of ink. The cat sleeps on. The city brightens below. You are alone with the last stars and the growing light. This night will become a date in textbooks, January 7th, 1610, the night Galileo observed the moons of Jupiter. But right now, it is not a date in a textbook. It is a real night, cold and long and full of wonder, shared by a man with a telescope and a visitor from the future. You were here. You saw what he saw. You felt what he felt. And now, as the dawn arrives and the stars fade, you close your eyes and let the night hold you one last time.